Okay, so we're going to be working on lesson 23, the quadratic formula. Now, the cool thing about quadratic formula is it allows you to factor any trinomial as long as it's in standard form. So standard form is ax squared plus bx plus c equals 0. Now, if it's not in standard form, you have to change it to standard form before you get rolling. So there's the basic equation. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And all a, b, and c are is, if you look, right, in front of x squared is the a, in front of x is b, and in front, well, right in front of the equal sign is the c. And they just get plugged into the formula. So what we're going to do here is I'm going to go through 3 examples, and I'll show you how to use the quadratic formula, and then I will show you that there's always an easier way to do stuff. So let's look at the first one here. X squared minus x minus 6 equals 0. All right, so the first thing we do is we write down what a is. A is equal to 1, b is equal to negative 1, and c is equal to negative 6. Then write down the formula right there. Plug in the numbers. Now, if you notice, see the b squared under here? I put the negative 1 in brackets. Even if it's positive, put it in brackets. It's a really good habit to get into because this is one of the most common mistakes is negative 1 squared is positive 1, and most people will put negative. And then the second most common mistake is over here. Negative 4 times 1 times negative 6. Negative 4 times negative 6 is a positive number. Many of you will make that mistake and leave it as a negative when it should be a positive. Okay, so plug in the numbers, do the math. There we go. Go down here, and then you know your end results, right? Because it's plus or minus. So it's 1 plus the square root of 25 or 1 minus the square root of 25 all over 2. So then what we do is we split them. There it is. 1 plus 5 divided by 2, and then 1 minus 5 divided by 2. So there are our answers. Now, that was a lot of work just to get 2 answers. The simpler way to do this one would have been to go up the top here, take your trinomial and factor it into 2 binomials like you normally would. Right? So you look at the negative in front of the 6, that tells you that the signs are different. Right? The only 2 factors of x squared are x and x. There's 4 factors of 6. The 2 we want are 3 and 2 because when they subtract, that gives you the 1. Then we split it, make it equal to 0, and then we have our answers as 3, negative 2, as you can see. Okay, that was the first example. Flip page, go to the second example. So second example is x squared plus 2x plus 1 equals 0. Again, list off what a, b, and c are. Write down the formula. Plug the numbers into the formula and do the math. Now, this is interesting. Look at this one. Oh, wow. If you notice under this one, it's 4 minus 4, so we end up with a 0 underneath there. Oh, cool. So when you actually do this one, you only get 1 answer. Now, if we did that trinomial-wise, factor the trinomial. Oh, x plus 1 and x plus 1. They're the same, so, right, we get a perfect square there. The only answer we need on that one is negative 1. All right. Third example. X squared plus x plus 5 equals 0. Okay, we list off a, b, and c. We write down the formula. We plug them into the formula. Now look at this one. This is really kind of interesting. 1 minus 20. We end up with negative 19 under the root symbol. That's weird. Can you take the square root of a negative number? No, you can't. So in this case, there's no solutions. Okay, so overall, the 3 examples are kind of listed here. We could have a quadratic that crosses the x-axis twice. We end up with 2 solutions. That was example number 1 on the previous page. The middle one here, it touches the x-axis, so there's actually only 1 answer, right? That would be if there's 0 underneath the radical symbol, root symbol, sorry. And the last one is it doesn't even go through the x-axis at all, and we have 0 x-intercept. So there's the 3 possibilities. Okay, last page. On the last one is an interesting example. It is a word problem, and most people hate word problems, but this one's kind of laid out quite nicely. If you're ever struggling with word problems, make sure you draw yourself a picture. It'll help you get through this quite easily. Okay, so what we have is we have an oil painting that's 50 by 60 centimeters, right? So draw a rectangle, and we see, oh yeah, 50 by 60. Could we find the area of that painting? Yeah, length times width, 50 times 60 is 3,000 centimeters squared. Now around it is a mat, right? We're framing this, so we want this lovely mat. And it has uniform dimensions all around the outside. So this distance here between the picture and the top would be x, to the side would be x, the bottom would be x, and the side would be x. Now, if you notice in the question, it says the area of the mat is twice the area of the painting. So if the area of the painting is 3,000 square centimeters, then the area of the mat is 6,000 square centimeters. Okay? And you can look here, we want to talk about the length and the width. Well, the length of this one, the up and down here, right, is 60, but there's also an x on the top and the x on the bottom. So we can write the equation as 60 plus 2x. The width on this is 50, but there's an x on either side, so it's 50 plus 2x. And then when we multiply those together, because it's length times width, we end up with 6,000. Well, you've learned already that for you to be able to solve an equation, it has to be equal to 0. Well, this one's not equal to 0. Well, can we rearrange it and do that? Yeah. We take the two binomials, we do FOIL, we rearrange them, bring the 6,000 over. Okay, so then we end up with 4x squared plus 220x minus 3,000 equals 0. Well, that's kind of a gross number to be working with. They're kind of large. So, interesting thing is, can we divide everything by 4? Well, of course we can, because we talked about something you can do to equations. If you do something to one side, you do it to the other. So we can reduce this down to x squared plus 55x minus 750 equals 0. Okay, now you're probably going to try to go, oh, that's a trinomial. I'm going to try to factor it into two binomials. Well, there's a dead giveaway back up here in the question. It says, how wide is the strip of exposed math to the nearest tenth of a centimeter? If the question asks you that, and you're talking about tenths or hundredths, you know right away you have to use the quadratic formula, because they're going to have some decimals in there. Okay, so we list off what A is, what B is, what C is. Write down the quadratic formula, plug in the numbers, do the math. Now, careful here. Here's another example. -4 times 1 times -750. That's going to be a positive number. Don't make that mistake there. Make sure you put the positive in, okay? So we do the math, and then we split them, right? -55 plus that, -55 minus that. Now, interesting thing. There's two answers. 11.3 centimeters and -66.3. Well, this one should kind of throw you for a loop there, right? It's -66.3. Well, can you have negative distance? Can you have a measurement that's negative? Well, no. Do we need that -66.3 to be able to do all this math? Of course, it's part of the math. Well, what's that known as? That's known as an extraneous root. It's an extra piece of information. You can't have negative distance, so that x equals -66.3 is gone, right out the window. All right. So that is lesson 23. Lesson 24 will be on the discriminant, which has to do with the quadratic formula.